most of the time we're not actually going to have cones anywhere, but I at least wanted you to see where we're getting these from. So when it says a section, basically what it's meaning is taking a slice of a cone. So if I do so diagonally, we end up with an ellipse. Okay? If we do so exactly straight across, which is kind of hard to get on here, we get a circle. So pretending that it's exactly straight across, we would get a circle. Does that make sense? There are other two options. Are going to be either a parabola, which is just going to be the like one half of it, or if you get both halves of it, basically you have an up and down parabola, it's called a hyperbola. So those are our four conic sections. Today we're going to be looking at our first two, which are going to be circles and parabolas. There's a typo that should have an A after the L or the S. Okay? So today we're covering circles and parabolas. So, what is a parabola? It is the graph of a quadratic, and that's kind of the only context that we looked at it up until now. We're actually going to take it kind of a step farther, and we're almost going to be looking at it more in a geometry type of mind instead. So a parabola is going to be the set of all points equal distance from a fixed point and a fixed line. So your focus is the fixed point. And your directrix is the fixed line. So if we were to look at what I was talking about, we have a parabola, and really up until now the only point that we've talked about is our vertex, and our vertex actually isn't either one of those. So when we're looking at our focus, it's actually going to be a point that's on the inside of our graph, and our directrix is going to be an imaginary line that is below or above our graph. And so basically any point that is on my parabola has to be the same distance from my inside point that it is from my line. Does that make sense? Now, the new thing that we're going to have now as well, as we've covered up and down parabolas, correct? But now, you can also have left and right parabola. So we're still talking about a focus being on the inside, but now our directrix is going to be vertical. So before now, we wouldn't talk about left and right parabolas because these don't pass our vertical line test, so they're not a function. But think about circles or ellipses. our left and right parabolas. We all agree. So this is kind of setting everything up with our vocab. Okay. Now we need to get our equation. We have to have our vocab to know what we're talking about, and then our equations to basically be able to solve everything. So we've seen our standard form before when we talked about graphing quadratics. So remember that it's y equals a times x minus h quantity squared plus a. Alright? And remember that that is an up and down parabola, so we're going to call that a vertical parabola. But we also have this new type, and that's going to be x equals y minus a quantity squared plus h. And that gives us our horizontal parabola. Now, remind me, for my vertical parabola, what does my opening depend on? If what is greater than the left hand? Yes, I agree. So remember that which way it opens depends on if A is positive or if A is negative. So for my vertical parabola, if A is positive, what's it going to do? It's going to open up. Horizontal, okay, and A is positive, it's gonna open to the right, okay? Because you can think about it as opening towards the positive stuff. So if our A is positive, it's gonna open towards the positive stuff. Now, for our A is negative, which direction is our vertical parabola going to point? Down. And then now, which direction will our horizontal point? The left. Now, it doesn't matter which one of these you have. Our vertex is going to be H, comma, A for both of these. But realize that when I look at my horizontal, my K is now what's on the inside, and my H is what's on the outside, because my K has to go with my Y. And then for our axis of symmetry, X equals H, or Y equals K. X equals H is going to be our axis of symmetry if we have a vertical, and Y equals K is going to be what it is if we have a horizontal. And then our last two sets of formulas are going to be our focus. So for our vertical, it's going to be H, comma, A plus 1 divided by 4A. And for our horizontal, it's going to be H plus 1 divided by 4A, comma, A. Then for our vertical direction, it's going to be Y equals A minus 1 divided by 4A. And then for our horizontal, it's X equals H minus 1 divided by 4A. Now remember, because we're not having a test over this, you don't have to worry about memorizing all of these. However, you will need to know how to apply them for our project that we do. Make sure that we all have them written down. And you want to make sure that you need to know how to use them. Yeah?
Which of the focus is this?
Okay, same order as the top. So the top one is vertical, the second one is horizontal, and the same thing for my direction. The top one is vertical, and the second one is I hopefully will make it. And the reason for that is because most of the time when we're looking for conic sections, we're going to be using them in application type problems. So I would rather skip the practice of applying these. Okay, and in the real world, you're not going to have all of these formulas memorized. You'll be able to have a sheet or pull it up or have a reference thing. As long as you know how to work these problems, that's going to be the big thing. Does that make sense? Do you have any questions on all of this stuff? Like I said, right now, there's just a lot of vocab and a lot of formulas. We kind of have to set everything up before we can start doing anything with it. So let's look at an example. So it says, write y equals 2x squared minus 12x plus 6 in standard form. And then it says, identify the vertex, axis of symmetry, and direction of the opening of the parabola. Now, is that in standard form right now? No. So remember that our standard form has something being squared, but it's like a parenthesis. Okay? Right now, our x is the only thing that's being squared. Yes. We don't want to divide it by 2 because notice if I divide it by 2, I have to divide everything by 2, and so I would have to divide my y by 2 as well. And I don't want an equation that has y divided by 2. Okay, what's the other word for subtracted? Factor it, yeah? Okay. So, but remember that the process that we need to use here is completing the square. So we have something that's not a perfect square, and we need to complete the square to make it a perfect square. Yes? But remember, in order to complete the square, our a value has to be 1. So, like was said, we do indeed have to factor out our 2 from our first 2 terms. Are we all okay with that? So then remember that our goal when it's completing the square is to make this parentheses into a perfect square. So that way when I factor it, I want to have a perfect square. Which means that we have to figure out what to add this. Yes? Yes.
Why did you not factor out the positive 6 on the very right?
Why did I factor out the 2 from the positive 6?
Yeah.
Because we only factored out from these first two. Because that's the only part that we're going to factor. So remember that when we're factoring, right, we're looking for what multiplies together to give me this, or my last term, that adds together to give me my middle term, right? Well, think about it. If I'm wanting it to factor to where we have the same number for both of those, right? And it has to add together to give me negative 6. Well, what's the only option that I have for those two numbers? Negative 3. Yeah, because the only way for them to add together to give me whatever b is if they're half of whatever my b is. Okay? But then if this is negative 3 and negative 3, remember they have to multiply together to give me my last term. So what is my missing piece right here? Positive 9. So I multiply them together. So remember that in general, our formula to the square is going to be b divided by 2 quantity squared. Are we all okay with that? But remember, we don't want to write it as x minus 3 times x minus 3, because that's what this would factor to right now. We want to write it as something squared, right? So it would factor to x minus 3 quantity squared. But that's the same thing as writing it 2 times. We just want to write it 1 time. Now, the other thing that we have to worry about is, am I allowed to write y equals here still if I just added in a random 9? No, because I can't say that this equation equals this equation if I just add a 9. Right? So we have to balance out our equation, which normally for us means I want to add it to both sides. But because this is a function, we want to keep our y by itself. So what's another way that we can balance out our equation instead? Correct. So we subtract it from the outside of our equation, right? Because then technically all I did was add 0, right? And that doesn't change any of my values. The only thing to be careful about is we added a 9 to the inside of the parentheses, right? Well, what's hanging out in front of the parentheses? A 2. And so that 2 applies to my 9. And so 2 times 9 actually gives us 18. So we didn't actually add 9, right? We added 18. So what does that mean we need to subtract? 18. And then from there, we're just going to simplify. So 6 minus 18 gives us -12. And now we can label all the things that they asked us to label. So what is our vertex going to be? So remember, we flip the sign of what's on the inside, so the outside is just the same. Okay? Then they also ask us to find the axis of symmetry. So what's that going to be? It's going to be 3, but remember it's an equation, so it is what? 3. X equals 3. So x equals 3. And then, what is our a value in this case? 2, so that is positive, so it's going to open up. Like I said, this question is all review because we covered something like this when we did our quadratics. But it's a good reminder, and it puts us all back on the same page. So did any of us have any questions over this?
Why you can't just add over into the middle of the equation and say that y equals it? Wouldn't it mean the same thing for x? Because then y and x are both fixed variables. If we had solved for them, wouldn't it make sense if you wouldn't be able to do that? So you just actually use the equation?
So what we were saying is, so I'm trying to make this a little bit simpler. So if I had something like y equals x plus 2, right? And say I wanted to add 4, okay, to both sides. As long as I do that to both sides, right, my equation is still true. Y plus 4 equals x plus 6. Agreed? Yeah. With me so far. So this is one way to do it. However, for us, when we have a function, we don't want plus 4 or anything like that with our y. So instead, what we did was that. Because if we add 4 to the inside, but then subtract 4 from the outside, right? 6 minus 4 still gives us that 2. Does that make sense? So basically, basically, we're doing the same thing by trying to balance out our equation. We're just writing it a little bit different, so that way we can keep our y by itself. Does that make sense? And notice the reason why it's not just a 9 here is because of that 2 on the outside. Yes, sir.
Oh, never mind.
Did you answer your own question?
I'm sorry. Yeah.
You're fine. Did you have any other questions?
Actually.
Okay.
So, do you also flip the sign for axis of symmetry and that's why it's positive right now? Instead of a negative?
Correct. Because it's on the inside.
Alright.
Because it's going to be whatever value is on your vertex. So since you have to flip it for your vertex, it gets flipped for your axis of symmetry.
And we found out this was all vertical because.
The x is what's being squared. Yes.
Right. And if it was,
What?
yeah, no.
Okay. Yes.
So whatever's on the inside has to be.
Yes. Whatever's inside of the parentheses, the sign will be flipped. Good.
That's when it works with like the x equals 3, that's not the value of x, so you would be able to plug that back in to check your work.
If you plug 3 back in, we should get -12.
Okay.
Because this is where my vertex is, and so remember that a point is going to be a pair of numbers. So if I plug in 3, well 3 minus 3 gives us 0. 0 squared is still 0. Anything times 0 is still 0. 0 minus 12 gives us -12.
So we can just plug that and then read back.
Yeah, if you wanted to check and make sure that your vertex is at the right spot. Yes.
So in this problem, what would it have showed, like what would it have looked like if it was horizontal instead of vertical?
So you would have had x equals 2y squared minus 12y plus 6.
Okay.
So basically your variables would have been
Oh, yeah, that makes sense.
okay with that? Alright, let's look at another example. So this one says write an equation for a parabola with a vertex at -2, -4, and a directrix at y equals 1. Then graph the equation. So our first step that we need to do is decide which equation we want to use. Do we want to use our vertical one, or do we want to use our horizontal one?
Is there a right or wrong answer to that? Or
Yes.
do you use either?
We use vertical because the directrix is right.
Yes, so notice that the first piece of information that it gives us is our vertex. But both of our equations have a vertex, right? So that doesn't really tell us much. But the second piece of information, which is the directrix, that is specific for what direction it's going to go. So which of our directions, so vertical or horizontal, has a directrix that has y equals? The vertical one. Does that make sense? So that's how we know that it's vertical. It's because our directrix says y equals something. So that tells me I want to use this formula. Y equals a times x minus a quantity squared plus a. And we need to now figure out what our a, h, and k are. Okay? But do I know any of those just right off the bat? Yeah, what do we know? Our h and our k, because we get that from our vertex. So what can we write?
Y equals
Plus 2 squared minus 4. Right? Because it would be minus a -2, which gives us a positive. So then, what's the last thing we have to find? Our a value. And that's where our directrix comes into play. So what is the formula for our vertical directrix?
Y equals a minus 1 over 4.
Alright, and we know a couple of those variables. So what do we know that y So then we can plug that all in, and that would be our final formula. Okay? So then they ask us to take that a step further and graph it. So where is my vertex going to be located? That would be here. Okay. Now, which direction is our graph going to go in? Down, because our A value is negative. Agreed? Okay, and the other thing we have to think about is, what does that A value also affect? Yeah, how much is it stretched or compressed, right? So it reminds me, the bigger that my number is, so 2, 10, 20, what is that going to do to my parabola? It stretches it, right, which makes it narrower. Okay, you gotta think about it like slope. The higher my slope is, right, the steeper it gets. So the more narrow my parabola gets. Now, the smaller that my number gets, so 1/2, 1/4, 1/20, remember that makes my parabola wider or compresses it. Okay? Now, 1/20th is kind of a hard number to graph. So basically, we're just looking at making sure that this is a really wide-looking parabola. Okay? Like if I was grading you on this, basically I would look at, hey, is your vertex in the right spot? Is it opening down? And can I tell that it's wider than what it would normally be? I'm not going to say, oh no, that looks like it's 1/15, not 1/20, so you don't get full credit. No. I'm just going to say, okay, it looks like you mean for it to be wider, so that's good. Yes?
You got that it was down because it's the negative one.
Correct. Yes, if it was positive, it would still be wider, but it would point up. Mhm.
So if it's smaller, it's smaller, if it's bigger, it's
So if it's between 0 and basically it's the absolute value. If it's between 0 and 1, it's going to make it wider. If it's bigger than 1, it's going to make it narrower. Does that make sense? And then the positive or the negative is what makes it point up or down. Good question? Okay. So, that's good. So let's look at another one.
So the only value that we really need to solve for is A.
Yeah, well, I mean, technically we like found ancient K, but they gave them to us as giving us the vertex.
So unless they ask for the equation, the first part of the question is basically, like, the first equation is basically just list what we were doing.
The first equation, what do you
Yeah, the y equals -1/20, because they gave us the points, it gave us the -2 and -4.
Yeah, but remember we had our vertex, they gave us that, but they didn't tell us our 1/20. So we had to find that in order to know how wide it was.
Yeah, so all we needed to solve for was,
Correct,
we
but,
didn't need the first equation unless it asks for it specifically.
correct, yes.
Okay. Okay.
But it could be like a two-part, like, question,
Yeah.
like, or it could just ask you for the equation and not ask you to graph it.
Yeah, I was asking, like, if they didn't ask for the equation, we wouldn't need that part of the problem.
Alright, so what do we notice about this one? We have y on both sides, and what is going on with our y right now? One of them squared. So what does that tell us? Yes. But more specifically, it's going to be a horizontal parabola this time instead. So we are going to complete the square first, like we did the first example that we did, but we're just going to do it with our y this time instead. But our steps are going to be the same. So our first step is going to be to get all of the stuff that is squared onto one side. So my y is being squared, so I want all my stuff with y's on one side. There is a 2 in front of our x, but we're going to take care of that remember we take our b value, which in this case is 4, divide that by 2, which gives us 2, and then square it, which gives us 4. But then since we have to keep our equation balanced, what do we also have to do? Subtract 4 on our outside. And this time, since we don't have a number hanging out in front, we don't have to worry about it being something different. It's just going to be the same. So then our whole reason why we complete the square is because what does x squared plus 4y plus 4 factor to? Y plus 2 times y plus 2. We picked our 4's in such a way to make sure that it factors into the same thing for both of our factors. That way then, we can just write it as y plus 2 squared. Notice that then I get a 6 on the outside. Now, once we've completed the square for the rest of it, this is where we want to take care of our 2. So what would I have to do in order to solve for x? Divide by 2. Okay? Now, whenever I write my first one, I don't want to write y plus 2 times squared divided by 2. I'm going to put a 1/2 instead, because remember that dividing by 2 is the same thing as multiplying by 1/2. And then the 6, I can go ahead and just divide that by 2 again.
So the 2 on the left side basically made your A.
Yes, it did. Yes, that's a good point.
So is that a different way to solve for A, or did that just happen coincidentally?
It happened because we already had our equation.
Okay.
And our last one we didn't have an equation, so here when it technically solved for A, it just happened by us solving for x. So it didn't come with an A value. Sometimes you might just have x by itself already, and in that case there wouldn't be an A value, or A value would just be 1. Yes?
So because it's 1/2, that means it's gonna open wide?
Correct. Yes. But it's going to open wider, which direction? To the right, because it's a horizontal graph this time. So what is my vertex going to be? Be careful.
No.
There is a -2 in it, but my 2 is with my y. So my 2 is going to be my k value.
So it'd be 3.
So it's going to be 3, comma, -2. That's why I said be careful.
Do the variables just switch if it's equal to
Correct.
X?
Yes, because your k is always with your y, your h is always with your x.
So if it's a horizontal thing, we just switched it.
Yep. And because my k is now what's on the inside, it's the one that gets the sign flipped, but the 3 is on the outside, so it doesn't get the sign flipped. So I am at 3, -2, and we said that this is going to be slightly wider than normal, and so, but it's going to open to the right, so that's what the fraction looks like.
So it doesn't need to be exact, just open it.
Now again, just opening a little bit wider. Question on that?
So if it was, so if that was a -1/2, then that would
Put
open
up
to
into
the
the
left.
left.
Okay.
So we have one last topic that we need to go over, which are our circles. Now we should have seen circles before in geometry, and they are a set of all points equal distance from a fixed point. Remember that that fixed point is called your center. radius. And so it is the length of any segment from the center to a point on the circle. So remember that your standard form is going to be x minus quantity squared plus y minus k quantity squared equals r squared. Where your center is h comma k and your radius is going to be r. Notice that this time, since both of my terms are being squared, both of them are inside parentheses, I have to flip the sign for both of them when I find my center.
So like the center is like the equivalent to the vertex.
Correct.
Okay.
But like I said, we flip both of them this time since they're both inside parentheses.
And what's the radius on the bottom? Is that just
R. But for your equation on the right hand side, it's going to be r squared. So like if it equals 16, then technically your radius would be 4. Does that make sense? Well, you have to take the square root of whatever's here in order to find r.
oh, okay.
Does that make sense?
So there's like an equation like the x minus a plus y minus k equals something.
Like 100, then your radius would be 10. You have to take the square root of that in order to find out what your radius is. Right, so let's look at an example. Our first one asks us to write the equation for this graph. So, notice that they give us 2 points. The first point that they give us is going to be our center. So notice that we can plug those in for h and k. But then our problem is that we don't know what that distance is. So it would be really nice if the points were just like directly across from each other, but they're not. Yes.
Could you go back to that last slide for like a split second?
I'll come back in a minute. We're running short on time, so I'll come back and do it. Did we all see where I plugged in the h and k? But then, like I said, our problem is that we need to know what this length is. So what formula do we have out there that gives us the length between 2 points? It's kind of like the design here. It is your distance formula. Yeah, so for us, we would want to plug in the 2 points that they give us. So we would have -3 minus 2 quantity squared plus 1 minus -1 quantity squared. So this would give us -5. -5 squared gives us 25. And then this would give us 2. And then 2 squared gives us 4. So we get the square root of 29. And that would be your radius. But remember that whenever I plug in my radius here, I then have to square it. Right? So if r is the square root of 29, then r squared would be 29. Yes.
Couldn't you just plug in the other thing into the? Oh, because that's okay. Yeah.
It doesn't matter the order here. I could have put my 2's first and my or like the opposite way, but since I'm subtracting and then squaring, we'll end up with the same.
Yeah. No, I was just thinking to put the other
Yeah.
point back into the.
But notice that if I take the square root, yeah, you get the same thing. So that's a good observation. Okay, let's look at one more. So we're gonna hold off on this one. So I will post this example like separately